Hello everybody, this is Rob Swatsky from the York campus of Hack, and welcome back to my Biology 121 Anatomy and Physiology 1 course. This is podcast 2.1c, Ions, Molecules, and Compounds. As we know, atoms contain three subatomic particles called protons, neutrons, and electrons. Remember that atoms have the same number of positively charged protons and negatively charged electrons, and because of this are electrically neutral, meaning that they do not have a net charge. When atoms interact with other atoms in chemical reactions, they can gain, lose, or share their electrons in order to become stable. An ion is an atom that has either gained or lost one or more electrons, so it now has an unequal number of protons and electrons and is no longer electrically neutral. The process of gaining or losing electrons is called ionization. We symbolize ions by writing its chemical symbol with a positive or negative superscript that represents the charge. If an atom loses one or more electrons, it becomes a positively charged ion. If an atom loses one electron, its charge is now positive 1. If it loses 2 electrons, its charge is now positive 2, etc. For example, an atom of sodium has 11 protons and 11 electrons. It has an equal number of positive and negative charges, so the atom is electrically neutral. A sodium atom has 2 electrons in its first electron shell, 8 electrons in its second electron shell, and only 1 electron in its third and outermost electron shell. This single electron can be lost. So after this electron is lost, our sodium atom has 10 electrons. It still has all of its 11 protons in its nucleus. It now has one more positive charge than negative charge, so it is now a sodium ion with a charge of positive 1 and is written as sodium Na with a positive superscript. Positively charged ions are called cations. You can remember this term using the phrase "plussy cats" or "I positively hate cats." If an atom gains one or more electrons, it becomes a negatively charged ion. If an atom gains 1 electron, its charge is now negative 1. If it gains 2 electrons, its charge is now negative 2, etc. For example, an atom of chlorine has 17 protons and 17 electrons. It has an equal number of positive and negative charges, so the atom is electrically neutral. A chlorine atom has 2 electrons in its first electron shell, 8 electrons in its second shell, and 7 electrons in its third and outermost electron shell. The third shell can hold up to 8 electrons. So the chlorine atom has room for one more electron, which it will accept to become full. So after it gains an electron, our chlorine atom has 18 electrons. It still has all of its 17 protons in its nucleus. It now has one more negative charge than positive charge, so it is now a chlorine ion with a charge of negative 1 and is written as the symbol for chlorine, Cl, with the negative charge superscript. Negatively charged ions are called anions. You can remember this term using the phrase a negative ion. We'll learn more about ions and ionic bonds in Podcast 2.2. Electrons can also be shared between two or more atoms. Atoms that share electrons bond together to form molecules. Molecules can contain two or more of the same or different atoms. Oxygen gas, O2, water, H2O, and glucose, C6H12O6, are all examples of molecules. A molecular formula is a symbolic way to represent the elements and number of atoms of each element that make up a molecule. For example, H2 is the molecular formula for one molecule of hydrogen gas. The subscript 2 represents the number of atoms of hydrogen in the molecule. In the molecular formula for carbon dioxide, CO2, one atom of carbon is sharing electrons with two atoms of oxygen. We don't include a subscript of 1 if there is just one atom of an element in a molecule. If a chemical substance contains atoms of two or more different elements, it is called a compound. Water, H2O, carbon dioxide, CO2, and sodium chloride or table salt, NaCl, are examples of compounds. All compounds are molecules, but not all molecules are compounds. Molecules of hydrogen gas, H2, nitrogen gas, N2, or oxygen gas, O2, are not compounds because they contain atoms of only one element. Free radicals are another example of a relationship between atoms and electrons. A free radical is an atom or group of atoms having an unpaired electron in its outermost electron shell. They can form through a variety of ways, including exposure to ultraviolet radiation through sunlight, X-rays, and normal metabolic reactions inside the body. An example of a free radical is superoxide, which is an oxygen molecule with an extra unpaired electron in its outermost shell. It is symbolized by adding a negative charge superscript to the molecular formula for oxygen gas. Because of this extra electron, free radicals are unstable and can react with and break down other molecules. To become stable, a free radical can either gain an electron from another molecule to form an electron pair, or it can lose its unpaired electron to another molecule. Both forms of electron exchange can lead to the destruction of the other molecules the free radicals are interacting with. Oxygen-derived free radicals are linked to cancer, diabetes, atherosclerosis, arthritis, and the cellular breakdown that occurs over time through aging. A diet rich in antioxidants, such as zinc, vitamin C and D, and beta-carotene, found in a variety of fruits and vegetables, are believed to reduce the damage caused by free radicals. Thanks for watching, and please feel free to contact me by email at rjswatsk@hack.edu if you have any questions or comments about the course.